Students, today we will talk about one topic which is known to all of you. We have studied this topic even in earlier standards. I am talking of air. We all know some basic things about air. We'll just kind of recap them and then move on to understanding something more about it. We know air is everywhere around us. It is one resource, natural resource, that is needed by all of us the most. We breathe air in, that is, we inhale and exhale. All plants, all animals do that kind of air to be inhaled or to be taken in. Air as a part of atmosphere is such a vital thing for us that survival of all of us totally depends on existence of air. Air is there in soil, air is there in water, air is there in atmosphere. Rather, atmosphere is nothing but air as a major constituent of it. We know the earth is like in a capsule of air around it. That atmosphere is pulled by earth, and that is the reason why so many things can happen on this planet. Like variety of life that has become possible on earth is attributed to presence of air or presence of atmosphere. You know, in this atmosphere, if we go a little beyond the first layer of atmosphere, which is quite close by, say about some first 14 kilometers or so, is troposphere. That is the main atmosphere that normally we talk about. All weather and everything we talk about, only this layer. This then comes, following this is stratosphere. Stratosphere. The first one is troposphere. I'll just write tropo. Now normally aeroplanes fly here. And we also have ozone layer. I'll discuss about ozone layer as we come to that topic somewhere here. Then we have mesosphere, following this third one, and then thermosphere. So this is atmosphere around us. Thick is this, and gradually they say up to first 100 kilometers, that is at least some atmosphere exists. Beyond that it becomes so thin that though it is there up to say more than 600 kilometers, its presence is almost negligible. We know and we have studied that air is a mixture of gases. All gases independently survive or remain in air around us, and we use them as per our need. The majority is of course nitrogen, that contributes to 78% of air. That way we don't need nitrogen as such for inhaling. But this nitrogen is needed for making up of proteins of your needs. You need proteins for your growth and everything. These proteins essentially come from nitrogen. But we cannot straightway take nitrogen and absorb it in our blood. So nitrogen goes into soil. There are some roots like bean or pea roots. They have nodules on them. Here bacteria, they fix the nitrogen, and from that soil so many plants take up nitrogen, and that, or particular nitrates, they take up, and these nitrates we consume, and that is how our proteins are, or need of our proteins is made up. So nitrogen is also needed, though we feel that okay, 78% is of no use to us. No, we need proteins, and that comes from nitrogen. Second 21% is oxygen, and all of us know that oxygen is one gas that we need the most for survival, because when we inhale the air, the oxygen is taken up by our blood, and then obviously it goes to cells where oxygen reacts with sugar. That sugar is burnt, I could say, and you produce energy for yourself. And also it produces some carbon dioxide, that is exhale out. So inhaling and exhaling keeps happening every alternate, taking oxygen, giving out carbon dioxide. So we have lungs, we can breathe in. Many animals have lungs. But some aquatic animals, they do not have lungs. They take oxygen in directly through some other kind of forms, like through skin or through some gills and so on. But every creature needs oxygen. Even plants do need oxygen for the same reason. They also need to convert sugar into energy, so that oxidation of sugar happens only when oxygen combines with it. So they also need oxygen. But luckily and fortunately, plants are not so selfish that they only will take oxygen in. They also produce oxygen as a part of photosynthesis and give out to this environment back, so that oxygen level is maintained. While doing so, they also need carbon dioxide. So excess carbon dioxide that we throw out, animals throw out, is then absorbed by these green leaves of plant, so that equilibrium is maintained of all gases. So carbon dioxide, as I just told you, is needed by plants for photosynthesis. And photosynthesis is one process that has given rise to life on the earth. We all depend on these autotrophs for food. Plants are autotrophs. So naturally we have to depend on them for food. So these are the uses of some gases which we have. Other than gases, what do we have in air? Air also has vapor, water vapor. How does it come? It comes directly by evaporation of mass water bodies. Earth has major water bodies like oceans. So evaporation takes place from the surface of these oceans, and that remains in air for a while, and slowly it goes up, forming clouds. Evaporation also happens, or typically called as transpiration, from plant leaves. So plants also give away or give out water vapor, and these water vapor also go into atmosphere. So that is called as transpiration. So evaporation and transpiration both add up to vapors in air around us. During monsoon period, vapors are more in atmosphere because more water is, it's raining as well. So the evaporation remains more in air, and slowly it once again becomes cloud and so on. So we have water vapors inside. We also have dust particles. That any sun rays coming into your room would show that dust particles. Sometimes we feel that dust particles are only there. No, they are everywhere, but they get visible only when sunlight shines on them, or they reflect that sunlight. So that is dust particles, or many even small organisms like bacteria, viruses. They also keep floating in air, and they are of course dangerous. That viruses can cause diseases. These are called as airborne diseases. You must have heard about COVID-19. Fortunately, that is not so much an airborne disease. Otherwise, such diseases will spread so rampant, you will find that they can spread within no time because air carries them. But not all viruses are carried by air. Some viruses, they settle down on water droplets and they don't spread so much, like coronavirus, that doesn't spread like that. So this is what is the composition of air. Now, atmosphere, moving air, everything, or your weather, they are a part of air, and that too, in particular, they are part of your first troposphere, that is the first layer of atmosphere around you. Now, coming to something about uses of air. We have just discussed about breathing and things around that we, for survival, need air. But other than that, air is also used in a variety of ways. For example, even plant fertilizer or those seeds of plant which are lighter in weight, they can just travel along air currents and drop somewhere, so they can generate and form new plant or new baby plant out of those seeds. So that is also done by air. We know air when moves is called as wind. So this wind has a velocity or speed, and using this wind speed, turbines are rotated. In earlier centuries, when electricity was not there, these moving turbines were used for grinding of wheat or other grain, and lifting water from wells and so on. But now you know that form of energy which is most convenient is electricity. So these days we rotate those windmill turbines or windmill blades and convert it to convenient form, that is electricity, which can be then transported. So for generating electricity there are windmills. One very important use of this moving air, that is called as wind. But it's very unfortunate, you know, that this such a precious, the most precious resource, natural resource, is being constantly polluted by we all. Animals do not pollute, plants do not pollute air. Then who pollutes air? So you have to just stand in front of mirror and look. You will find the culprit. So you know that you and me and all human beings, they are responsible for polluting air. So we know we have industries, we know we use vehicles, we burn different types of fuels like coal, like wood or like petroleum products and so on. All of them produce some harmful gases like carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide and so on. All these gases, they finally mix into air, and that is what we call as pollution of air. And quality of air constantly degrades, deteriorates with more use of such industrial kind of burning or vehicular traffic and everything. So we must take care that we must maintain vehicles so well that it does not produce any pollution or produces very little pollution. We should not let these pollutants get into the air. We must see to it that we can somehow manage with them, finish them and keep our air clean so that there could be generations after generations of we all and all creatures on this earth can survive happily, and you young generation should take that responsibility now that we will not pollute this planet. Mainly air will not be polluted, water will not be polluted, and we'll give a rich atmosphere to next generations to come. With this understanding of air, gases, its uses, pollution and so on, we will now go for actual activities based on all these concepts we have discussed so far. Little bit, but we'll try activities now. We have discussed that air is a mixture of gases. We'll try to make one gas, and that's nothing but we are making air, but that is gas of air, that is carbon dioxide. To make carbon dioxide, we need to make some reaction, chemical reaction. You might have heard this term, chemical reaction. We'll be using vinegar. This is something you can even get from your kitchen. Today we'll be consuming this, but for next time when you do the activity, you can get it from your kitchen. You can ask your mother to give you some vinegar. I'm just opening this bottle. See, I opened this bottle. This has sodium bicarbonate. Again, this is something which is easily available in your kitchen. Soda bicarb or sodium bicarbonate. Your mother might be giving you if you have some indigestion. Or you can also use ENO in this experiment. I'm just opening this mouth of this balloon and putting some sodium bicarbonate into this balloon. This you should do little carefully. So I transferred content from this bottle into the balloon. Now take this bottle again. Next step is to be done carefully. I am just stretching this mouth and covering it on mouth of the bottle without this powder getting dropped into the bottle. This powder is protected, that is here. This sodium bicarbonate filled in this balloon is still not reacting with vinegar. So this balloon is placed this way. Now get ready for the actual action. I'll be doing this, just taking this up. So you know with gravity what will happen? That powder will fall into vinegar and reaction will start. And as the reaction starts, it produces carbon dioxide, which will be collected in this balloon and balloon will inflate. Okay, so let us get ready. I'm just stretching this balloon a little bit so you get better inflation of balloon. Hold your finger on this mouth of balloon, otherwise this may jump off, and then let it go inside. Is it not a great wonder to see? This balloon is getting filled with carbon dioxide. I am just shaking the bottle so additional reaction can happen. So this is carbon dioxide collected in balloon. Okay, I can take this out and release it in air. So you know that this carbon dioxide gets mixed with air from outside and disappears, because air is nothing but mixture of gases. So that has gone into air and disappeared. Hello friends, we'll do one experiment which is quite familiar to you as well. It will be a candle placed in a plate with water, and I'll be putting this jar over that. Let us see what happens when I do that. I am pouring some water into this plate. Then let us light the candle. And then finally we'll place this glass jar on top of this candle. Let us wait and watch. You can easily notice that water level in this jar has risen up to here, whereas water level in plate is just here. So there is much difference between the two levels. Now you have to do one interesting activity. I am telling you have to do, because I cannot do it now. I'll just explain how to do it, and rest is up to you. See, we will practically see how transpiration gives out vapor, water vapor from, or you have to do it with a plant, and you have to wait for at least few hours or a few days. What will you do? You will take a plastic bag like this, take any one small branch of a plant and put so many leaves inside of this plastic bag, and just tie it at some place. Like if I am putting all of them together, then in the bottom somewhere I had to tie it using a thread. Just make a knot out here. So few leaves are locked inside, but they are well connected to the plant. So keep this plant back into sunlight. Let it be as if it is, if you are watering it every day, keep doing that. After a day or two, you will find this plastic bag is filled with water vapor and even some water. That means the plant has given out that water vapor, which has condensed and formed water again, simply proving that plant also gives out water or water vapor into air. Students, we will now make a wonderful project of a small windmill. Now we know that we need wind to rotate the blades, and that natural wind is not around us. So we will make a blowing windmill. When you blow, that means you are throwing air from your lungs out against the blades of that windmill. These blades will rotate, and they rotate a generator or something inside a generator, that is nothing but a copper coil in magnets. So when it rotates, it generates electricity, and in this project we will see that it glows 2, 3, 4 number of LEDs, light emitting diodes or lights, so that your lung power used as wind is glowing the bulbs. That means you are producing electricity in this project. So let's get ready to make a wonderful windmill. Hello students, we'll be doing one blowing windmill today. Let us look at the material available around us. This is a base on which windmill will rest. This is a fan which will fit in the front of this dynamo, which is already having black and red wires. 2 foam pieces with adhesive tapes on different sides. 2 metal strips which will help connect these 4 LEDs in parallel. So with this material we will be making one simple windmill. This has adhesive tape on one side. So remove its release paper and put it on one edge of this white colored sunboard like this. Here we have 4 LEDs. We know that LED has one terminal which is longer than the other terminal. The longer one is positive and the smaller one is negative. Spread these 2 terminals in a way that we have to place them here. These LEDs we have to place them here. Each LED will have its positive coming on same side, negative on one side. All 4 LEDs you will have to place like that. So here is positive. I am just spreading it, then bending this here. So once again note where is positive. So here is positive, and remove these adhesive tapes, release paper, and put these LEDs on foam, keeping some gap between them. So this release paper is removed from both the sides. This is positive, this is negative. I am placing it in this way, like somebody riding on a horse. This will be fixed here, and these 2 terminals will automatically get pasted on 2 adhesive tapes. In this we have placed 4 LEDs in the same way, having their negatives on one side and positives on the other side. Now next step, take this dynamo. This red wire is coming from one side. Insert this red wire into the hole of this metal strip. Twist this. Before you insert, of course, you should bring these all strands together like a single thread, and then insert it through this hole. Insert these wires into these holes and twist it here. You can press that to your fingers, using your fingers like this. Then paste this metal strip, one coming from red wire, on positive side of this LED terminals. Press them with your hands like this, and one coming from black wire onto the negative side of these 4 LED terminals. Now final assembly would be connecting this to the fan and placing it on top of this foam piece. Now remove the release paper from one side, paste it on in the middle of the other edge of this board like this. Now you have to paste this dynamo on top of this. Make sure that its shaft is projecting outside of this base. Now you have to finally press fit this fan into this shaft. Hold it in your finger and carefully press fit it like this. Your assembly is ready, your product is also ready. Now blow air from the front of this fan and you will see that LEDs will glow, showing that electricity is generated using this dynamo and your wind energy from your lungs, and this is circulated through 4 LEDs in parallel, and all 4 are glowing due to generation of electricity. Take a look.